Self-inductance for coil, solenoid, and toroid. First of all, we'll consider that for a plain circular coil. Suppose it has the radius small r. The magnetic field produces mu 0 n I over 2r. And flux is B into A, L, that is N upon I, phi. In place of this phi, we have written B into A. Put the value of B here. A, is pi r square, and B written over here mu naught N I over 2r. R gets cancelled. This is the relation mu 0 upon 2. I also gets cancelled. This is pi n square r. That is the value of self-inductance for a plain circular coil. If you are putting the coils in some medium, obviously this mu naught will be replaced by mu. Mu naught is the permeability of free space, whereas mu is the permeability of the medium concerned over there. Let's consider now a solenoid. For solenoid, suppose the length is L and diameter of wire is D. If there are n turns in the solenoid, then n into D, this is going to be L. You could say n upon L, this is 1 upon D, and this will be turn density. N upon L, number of turns per unit length, this is known as turn density. Self-inductance, this is again N upon I phi, that is B into A. You could write it as Na upon I in place of B. You will write mu naught N I. This is cancelled. Self-inductance is mu naught is small n capital N E. This becomes the self-inductance for the solenoid. If you write this as N into L, then in that case you'll find L proportional to N square. Volume should be constant as shown over here. And if you convert this capital N upon L, then you are going to get the result L proportional to capital N square, provided A upon L is constant. Similarly, you can find the value of self-inductance for toroid. Here also you will use the same relation N phi upon I, and you get this relation L equal to mu naught upon 2r n square r square. R is going to be the radius of, toroid. You must remember, toroid is this way, a solenoid bent in the form of circle. Small r is radius of solenoid and capital R is the radius of toroid. One very important formula we have to find out, that is the formula for magnetic energy density. Magnetic energy density means the energy per unit volume. Energy, for solenoid or even for the coil will be half Li square divided by the volume, and this length, this is self-inductance for solenoid, and that's given over here mu naught N A. This could be rewritten as 1 upon 2b I square, this mu naught. Mu naught could be written as mu naught square upon mu naught, and here this could be written as N into L. This is also N square. You see, mu naught square is small n square and I square. This is the value of B magnetic field. So what remains here is B square upon 2 mu naught. This is AL, this is volume. both are same, get cancelled. Energy density becomes B square upon 2 mu naught. This is quite comparable with the relation half epsilon naught E square, there in the case of electrostatic energy density. Magnetic energy density will be given by V square upon 2 mu naught, whereas the electrostatic energy density will be given by half epsilon naught E square. Means energy density always depends on the square of the field.